Hello, my name is Philip Ontfroy, and I'm presenting on the RayCycle Initiative, which is a project that my polymer processing research team and I launched about a year ago, Professor Wakabayashi's lab in Bucknell University's Laboratory for Advanced Manufacturing of Polymeric Systems. When the pandemic sent us home away from our lab in March 2020, we started this project as a means of virtually motivating the local college community to collect difficult to recycle plastics, like grocery bags and K-cups, and then our team came back in fall 2020 to process them into research materials. Our motivation was that the US generates a lot of plastic waste a year, but a low percentage of it is recycled, mostly due to contamination and undesired effects that certain plastics have on industrial recycling machinery. Often these difficult to recycle plastic waste are plastics such as high-density polyethylene, low-density polyethylene, and polypropylene. Our goal was to get students to collect a bunch of materials that would otherwise not be recycled, and then we would innovate and invent a new method of recycling plastic waste using our novel polymer processing technique called solid-state melt extrusion. Solid-state melt extrusion shears material after it's been input into solid state and mixes it evenly in molten state. And we had two goals regarding processing plastic pellets this way. The first was to generate actual useful products out of the recycled grocery bag and bottle cap plastic to give back to the community. Then the second goal was to characterize the thermal mechanical properties of these new ray pellets and compare them to virgin material. In regards to product creation, we then, after we created the pellets using SSME, we injection molded these pellets into products such as cookie cutters and packaged box cutters that we are now distributing. In regards to the characterization, we've carried out thermal and mechanical property analysis to compare our recycled ray plastics to virgin plastics that have yet to be processed. And we used differential scanning calorimetry, thermal gravimetric analysis, and tensile testing. Our initial results are promising for the prospect of using SSME for recycling, as the thermal properties of ray plastics determined through DSC and TGA were very similar between virgin and ray recycled plastics. As shown on this slide, melting temperatures, degradation temperatures, and percent crystallinity indicated close similarities between ray and virgin plastics. These thermal results, as well as later tensile results, actually revealed that the LDPE used in grocery bags are actually made out of linear LDPE, or LLDPE. That can be shown by the peaks in the DSC curve shown here. Also, polypropylene was determined to be not as pure as originally anticipated in K-cups, as the DSC graph shows that the ray recycled PP is not very smooth and there's a lot of impurities. However, the TGA results show that the thermal degradation temperature is pretty similar between each sample. Mechanical results, such as yield strength, strain at break, and Young's modulus, were slightly less consistent, but still showed that ray recycled plastics were comparable. Interestingly, for yield strength and Young's modulus, the ray LDP pellets actually came out above the virgin LLDPE. And especially with Young's modulus, or stiffness, the error bars and the measurements for the LLDPE and the HDPE show that ray materials are pretty comparable. Even though similar to the DSC graphs, ray PP was the most far off from its virgin analog out of any of the plastics. Shown here are the different plastics we collected, then the names of the plastic pellets we created in green, and the resulting products we created, the cookie cutters, box cutters, and plaques. In the end, we determined that LDPE ray recycled plastic in common products is actually a subset called linear LDPE, and ray recycled plastics are comparable, even though the process still needs to be fine-tuned. Thermal properties are more consistent than mechanical properties. The future work goals are to improve the quality of ray PP to hopefully get it more comparable to virgin material by processing bottle caps alone and then trying to hopefully work with K-cups more to determine how to make them more pure. And additionally, we hope to further characterize the Ray HD, Ray LD, and Ray PP pellets The biggest takeaway is that recycling through SSME has determined to be viable.